Hello guys, so today we are here to solve the second problem in the unique path series. Yesterday we had solved the first problem, and in today's problem we are going to solve the same problem. So same idea is going to be applicable, but in addition to the same basic idea, we are going to face one challenge here. The challenge is that one of the cells is going to have a restriction now, and we have to, the robo in question is not able to pass through go through this obstacle. And so but it can go through all the unobstacled cells, and given this restriction, we need to find out and tell how many ways are there from the you know from the 0 0 cell to go to the m-1 n-1 cell. Okay, so let's start doing it. So I want to give some understanding. Okay, so let me okay, so we'll create a grid here. So this is the grid that we are going to have. Okay, here is the robot. So see, this robot can go down or it can go right. So to go to this cell, the robot has only, it can come to this cell through only this way. Since the robot is restricted, it can only go down or it can go right. So to come to this cell, it can only come through this cell. To come to this cell, it can only come through this cell. To come to this cell, it can only come through this cell. And also, to come to this cell, it can only come from this cell, which is just above it. And to come to this cell, it can only come through this cell above it. It cannot come from any other cell. This cell, it can only come from this cell or this cell. Okay, so this is the thing. And also, the additional factor here is that there is going to be an obstacle in some of the cells. So given the obstacles, how are we going to solve this problem? So, let me solve this problem with these restrictions. Okay. So yeah, okay. So we have understood now, what is the problem and how to solve it. So now we will go and solve the problem. So it is possible that the first grid itself, 0 and 0 is equal to 1. So obstacle is there in that first grid itself. If that is the case, then if the obstacle is there in this first grid itself, then we just can't go to this cell. So we are forced to return 0. Okay. Otherwise, obstacle grid 0 0 is equal to 1. Okay, and now we are going to fill the we are going to fill the cells with the value that how many ways we can come to those cells. So we have negated the possibility that the 0 0 cell is not, this cell is not occupied. So if this cell is not occupied, then we can come to this cell, and from this cell we can come to this cell. So, and to in order to come to this cell, we can only come to this second cell from this cell. Okay, and we can only come to this cell from this cell. Okay, so let's populate, like we can come to this cell in one way, and we can only come to this second cell on the row, 0th row, from the left hand cell. So to come to this cell, there is only one, only one way, and that is one way. Same for this cell also. And if you notice, if there is no obstacle, then to come to this cell also there is only one way, because you can come from only this cell above. And same for this, only one cell above we can come to this cell. So now we'll just okay, just will fulfill those things. Okay, so now for int I is equal to 1, already we have taken care of the 0 value. So int obstacle grid dot 0 dot length plus I. If this is the case, then so we are going to first check if obstacle grid of 0 and I is equal to 1. If it is equal to 1, then what we are going to do? If it is equal to 1, then what we are going to do, that we are going to put the value 0. Why we are going to put the value 0? Because that is the obstacle, and there is no way that we can reach that cell, or we can get a path out of that cell. So we are going to put 0 in that. Otherwise we can definitely reach that cell. And if we are able to reach that cell, how can we reach that cell? Remember, we are only considering right now the 0th row, the 0th row. This mean, I mean this row. I meant to say this row. So we can come to this cell only from the cell which is on the left of it. And there is only one way to come to that cell. So whatever is the value in that left cell, we are going to copy in that, current cell also. So this is the logic. Same for our, this cell also. I or 1. Obstacle grid, and then I and the 0th, because we are considering the 0th column. So if there is some value which is equal to 1, then what we are going to do, if it is equal to 1, then there is no way that we can reach that cell, and we are going to put 0 in that cell. And if it is 0, the cells subsequent to it also will be 0. Else what we are going to do, we are going to copy the number of ways we can reach that cell from the previous cell. Why previous cell which is just on top of it? Because there is only one way. We are considering the first column, and in that column, to reach any cell, we can only come down from a cell above it. So that's why we are going to do I minus 1, and then 0. Okay, like that we have done. And then for int I is equal to 1, I less than obstacle grid dot length for int I is, no, we have to take different variables. J is equal to 1, j is less than obstacle grid of I dot length. In this case, if obstacle grid of I and j j is not equal to 0, then in that case what we are going to do, we are going to do obstacle grid I j is equal to obstacle grid previous cell on top of it plus obstacle grid cell in the previous column. So this is the sum of these two. Either we can, to reach any cell, either we can come on from top of it or we can come from the left of it. Okay. Else if the current cell is equal to 1, then in that case what we are going to do, we are going to put 0 in that cell. And at the end, what we are going to do, obstacle grid dot length minus 1 obstacle grid and then 0 dot length minus 1. So this is the final value that we are going to return. Okay, and now let's run this and see how this solution is being. So there is some problem in this obstacle grid. Oh yes, plus I, we are doing such a silly mistake. Okay, so we are making some mistake here. Let me fix it up. Okay, perfect. So now we'll sum this. So this is also coming correctly, and see the runtime is 0 ms. So it's a good solution and it's a decent solution. Thanks a lot. If you have any doubt, post it in the comments and I'll be glad to answer those questions.